Now, let's take a look at this example 4.4.6. The author asks us to determine the volume of the solid bounded by the paraboloid z is equal to 4 minus x squared minus y squared and z is equal to 0. So, how to solve this type of problem? Again, you have to recall the formula, the correct formula to solve this problem. And the question asking us to determine the volume of the solid. Therefore, we have to use this formula, such as V is equal to double integral F R theta R dr d theta. Before this, we have agreed z is equal to some function x, y. So right now, according to the question, z is given as 4 minus x squared minus y squared. Right now, what should we do? We have to transform the function z that is written in terms of variable xy to a function written into variable r theta. Therefore, we have to recall the relation between rectangular and polar coordinate. So I will get 4 minus x squared plus y squared. According to the relation between rectangular and polar coordinates, x squared plus y squared is equal to r squared. Therefore, I will have 4 minus r squared. And what should I do right after this? I have to sketch the region R. And before we try to sketch region R, we have to sketch the surface first. And this surface lies in three-dimensional coordinate system that involve x, y, and z axis. Okay, we will have exactly like what we have in the module, which is a paraboloid. Okay, and this paraboloid is represented by 4 minus x squared minus y squared. And you should always remember, our region R always lies in two-dimensional coordinate system that involve variable x and variable y, or x and y axis. So if you look at your surface from three-dimensional coordinate system and then you try to map onto xy plane in two-dimensional coordinate system, therefore on xy plane there will be no coordinate z. Okay, z, you will always assume z is equal to 0. Okay, by assuming z equal to 0, 4 minus x squared minus y squared equal to 0. X squared plus y squared equal to 0. R not 0. X squared plus y squared equal to 4. R squared equal to 4. R is equal to 2. You will end up with a circle in polar coordinate system. So this is your region R. And then try to set up your double integral to determine the volume in polar coordinate system. So I will have double integral, and our function fr theta just now is 4 minus r squared, and the way we expand our dA is equal to r dr d theta. According to this region R, your r will start at r is equal to 0 until r is equal to 2, and since your region R occupies all four quadrants, therefore theta is from 0 until 2 pi. Okay, let's try to solve this question together. So you will get 4r minus r cubed over 3, then you will evaluate it from r is equal to 0 until 2. I will get 4 times 2, 8 minus 2 cubed, which is 8 over 3, which is equivalent to 16 over 3. And then integrate 16 over 3 with respect to theta for theta is equal to 0 until 2 pi. And then I did some mistake over here. I forget to times the whole equation with r. So let me erase this part. Okay, let us do this question once again. Okay, so I will get 4r minus r cubed, the r from 0 until 2, then I will get 4r squared over 2 minus r4 over 4, and then I will evaluate from 0 until 2. In this case, I will get 2 times 2 to the power of 2, 8. Minus 16 over 4, which is 4. Then I will integrate 4 with respect to theta, where theta is equal to 0 until 2 pi. I will get 4 theta, and then I'm going to evaluate it from theta is equal to 0 until 2 pi, and my final answer will be 8 pi. So this is the solution for question example 4.4.6. I hope I did my part to explain it very well. So I really hope you can look at example 4.7 to answer this question based on your own understanding. The process will remain the same. Now let's discuss about example 4.4.8. If you have access to question from previous semesters, you will see that this kind of question can be considered as famous question, where we tend to test whether you understand the process to change from rectangular coordinate to polar coordinate system and solve the double integral by using polar coordinates. Okay, so basically the question will be very clear, where we will ask you to sketch the region R first, and then you will see the region R that you will sketch later somehow belongs to a type of polar curve in polar coordinates. And then it should trigger something in your mind that that question can be easily solved by using polar coordinates, not the other way around. So let's try to look at this question. Okay, in this first question, the author asks you to sketch the region R. So right now, remember, your region R always lies in two-dimensional coordinate system that involve y versus x-axis. And then, according to the question given to you, the double integral is written in terms of type 1, which is dy dx. So I need to sketch an arrow, and this arrow should be bottom up, and then it should be parallel to y-axis. So it should give you something such as this curve that you will sketch later, it will touch y is equal to 0, and the location of y is equal to 0 lies on x-axis. So this is y is equal to 0, and then right after that it will touch y is equal to set 2x minus x squared. So this is actually a equation, so you are not familiar with this equation, so you have to do something to modify the equation into form you are familiar with. So right now, what should I do? I have to get rid of the set notation. I will get y squared is equal to 2x minus x squared, and then I will get x squared plus y squared is equal to 2x. By right, it should tell us that this equation will produce a families of circle according to what we have learned in topic 1.5. Then by using a proper method, which is completing the square, you will get x minus 1 squared plus y squared is equal to 1, which is you will end up with a circle center at 1, 0, and at the same time it will give you radius equal to 1. And then please take a look at the limits of variable x, which is it should start at x is equal to 0, which is at the origin, and then it should stop at x is equal to 2. So you will end up with a circle center at 1, 0 and having 1 as the radius. So I will sketch the circle now. So this will be our circle. So according to the limits given to us, again, it should start at y is equal to 0, and then it will touch the portion of the circle which lies at the first quadrant, hence explain why you have positive set 2x minus x squared. And at the same time, the limit for x ranging from x is equal to 0 until x is equal to 2. Therefore, you should know that this is your region R. And then here come the next question. Right after you manage to identify the region R based on the limits given to us, now you proceed to the next question, such as we ask you to evaluate the integral by changing to polar coordinate. Evaluate the multiple integral by changing to polar coordinate. Okay, the function given to us is fxy equal to set x squared plus y squared. So you have to transform it to fr theta. Then you will get r squared, which is as simple as r. And then try to set up your own double integral. Double integral y equal to 0 until 2x minus x squared and x equal to 0 until 2 set x squared plus y squared equal to dy dx equal to double integral x squared plus y squared equal to r, dy dx is equal to r dr d theta. So if this is our region R will start at the pole r is equal to 0, and then it will touch the curve, and the curve is represented by this equation, which is x squared plus y squared equal to 2x. Then you transform this equation into polar coordinates. You will get r squared equal to 2 r cosine theta. R is equal to 2 cosine theta. So the upper limit with respect to variable r is equal to 2 cosine theta. Meanwhile, since this region R lies in the first quadrant, hence explain why theta is from 0 until pi over 2. Let's try to solve this problem. Then you will get R cube over 3, you evaluate from 0 until 2 cosine theta, you will get 1 over 3 2 cosine theta cube, which is 8 over 3 cosine cube theta. So right now I will integrate from theta is equal to 0 until pi over 2, 8 over 3 cosine cube theta d theta, I will get 8 over 3 integrate theta is equal to 0 until pi over 2 cosine cube theta d theta. When you try to answer this question, please recall that all the techniques that you have required in any calculus subject, we have to do something with this equation, such as 8 over 3. Okay, before that, maybe we can do something with here, which is we can write cosine cube theta equal to cosine theta cosine squared theta. Okay, and then you can rewrite it in term of cosine theta 1 minus sine squared theta, since cosine squared theta plus sine squared theta equal to 1. So right now, integration of theta equal to 0 until 8 over 3, don't forget 8 over 3, pi over 2 cosine cube theta d theta is equal to 8 over 3 theta equal to 0 until pi over 2 cosine theta 1 minus sine squared theta d theta. So you will apply u substitution to solve this integration, such as let u equal to sine theta du equal to cosine theta d theta. Therefore 1 minus u squared du, you will get u minus u cube over 3, then you will get sine theta minus sine theta cube over 3, evaluate from theta equal to 0 until pi over 2. Don't forget 8 over 3 over here. Then I will get 8 over 3 sine pi over 2 minus sine pi over 2 cube over 3 minus 0. 8 over 3 times 1 minus 1 over 3, 8 over 3 times 2 over 3, which is equivalent to 16 over 9. So this will be your final answer. Okay, I really hope you can benefit from the videos, and I think that's it for topic about 4.4, double integral in polar coordinates. So I really hope you can spend some time to answer the question here in exercise 4.4, just to make sure you are familiar with the question, so that right after you're familiar with the question, you know how to solve the problems, or else you will see that a lot of difficulties just to answer a question related to double integral in polar coordinates. Don't forget to like and comment, or don't forget to subscribe my channel Until next video, bye.